My name is Dr. Mike Pitts. I work for Chemistry Innovation and my job title is Sustainability Manager. My job is to try to get chemists to understand the opportunities around sustainability. So sustainability problems that we have as a society and other downstream industries that need chemistry to find out what their sustainability issues are and solve them using technology. The way you do that is to get out and talk to a lot of people, networking. I need to know a lot of industrial chemists, sustainability managers in big companies, in small companies, academics who are real leaders in this field, so I understand and know what's going on in the technology, but also where the problems are. Everything's made of chemistry, made of chemicals, so you need chemistry to help solve those problems. Chemistry is vital to the future of sustainability. I mean, most of our issues with material, and we have a very, we're a consumer society, we're a throwaway society. We use a lot of stuff, and what we need to do is use that stuff more efficiently. And that's basically about managing molecules and atoms, and that's what chemists do. You can't be a sustainable nation without good chemistry. We need more good chemists who think the right way. To do my job well, you need interpersonal skills. The laptop and the mobile phone, really. You're on the roads and you're out seeing people. A lot of it does get kept in your brain. I've got a great team in the office who back me up in terms of keeping in touch with everyone, and keeping a record of all the things you've seen is important. Well, I did chemistry at university because that was the subject I enjoyed most at school. No two ways about it. I did do a sandwich year then, so I did a year. My third year was in industry, where I worked for a big pharma company. And the one thing that came back with me from the end of that year was that I wanted to do a PhD, because the people who were higher paid and higher up the ladder were all had PhDs. And when I did do a PhD, it was a lot of fun. It's probably the best fun I've had in my career. 3 years, it's your own work, it's your own piece of science. And it was quite successful. We got some good publications out of it, so I really enjoyed that. From then, to do the kind of job I do, you have to have some kind of industrial experience. You have to have that experience of going out and actually developing commercial products. So I worked for several different small technology companies developing applications of catalyst technology for making pharmaceutical products, basically. So quite complicated molecules and better ways of making them using chemistry, catalysis and some microwave technology. I got quite involved in using microwaves and what we call flow chemistry, doing things in flow rather than in big buckets, so that it's safer and quicker and can be cleaner. So from there, once I had some success at doing that, a role like this is easier, because you've got that experience of taking something through from an idea in the lab to an actual commercial product. One of the best ways to grow is to get out there and talk about the issues and the problems that we're there to solve, and being able to present clearly and concisely about it all is important. I applied to become a chartered chemist when I was doing my postdoctoral work, when I was living in Austria, working in the University of Vienna. And that was to demonstrate that I had developed as a person. The continued professional development component of that really helps you demonstrate that you're doing more than just doing the science, you're developing other skills. So that when I came back, that helped me with my employability. I had no problem getting a job when I came back to the UK, and I've had no problem moving since. Well, meeting new people was a lot of fun. Hearing about great science, and whenever you get a success, when we can start a new project off that you know is going to deliver something really good. A lot of the time we're working with relatively mature science, it's something that an academic has taken to a point where it's proven that it works, and now it's taking it through to where we can use it commercially, to that kind of level. And when you see some of those projects get started and you get the funding in, and there's millions of pounds next to that project, and that enables groups to do work they really want to do, and that's fantastic. That's the real buzz. And when people come back time and again to say, can you help us, and you know you're doing a good job.